Hey guys, Miss Beller here. I got one more gas law for us. It's called the ideal gas law. I call it PivNERT. P times V equals N times R times T. Kind of looks like PivNERT. Just a friendly reminder, STP stands for standard temperature and pressure. So if we are at STP, our standard temperature is 0 Celsius, which is the same as 273 Kelvin. And our standard pressure is the pressure at sea level, which is 1 atmosphere. All right, so the ideal gas law is an equation that we're going to use if we're not at standard temperature or standard pressure. So it helps us figure out an unknown condition. All of these guys here are multiplication, so multiply times multiply and multiply. So first, P stands for pressure, and the pressure is going to be measured in atmospheres. Next, we have V, which is the volume, and that's going to be measured in liters. So we're taking the pressure times the volume. On the other side, N represents the number of moles. And for some of you, you know what moles are. Some of you are watching this video and we haven't talked about moles yet. So if you don't know what a mole is, it's going to be a way we count particles. So think of N as like number of particles. That's not exactly what the mole is, but it will work for right now. It's how many particles there are. It's just a unit we use to count particles. R is our universal gas constant, and it always has this value 0.0821, and it has a scary looking unit, ATM times liters divided by mole times K, and that's really just so everything cancels out. So the scary unit is to get everything to cancel. And last, T is temperature, and we always measure temperature in Kelvin for gas laws. So PV equals nRT, pressure volume equals moles times the R constant times the temperature. So when might you want to use the ideal gas law? Well, all of our other gas laws, Boyle's law, Charles' law, those guys, are talking about calculating the change in a variable. For example, we have a pressure 1 and we have a pressure 2, right? The pressure is changing and we want to see the relationship. So if I change the pressure, what does that do to the volume? The ideal gas law is only showing a current situation. So a snapshot here, right in this moment, what is the pressure? Right in this moment, what is the temperature? It uses all 4 variables, so the volume, the pressure, the temperature, and the number of moles, the number of particles. Nothing needs to be constant except for the R value. And then don't forget that we always want units, and our final answer should have units as well. So here's a typical PivNERT problem. I have 2.3 moles of CO2 gas at STP. How many liters of CO2 do I have? So I always like to list what's given. So I have P is 1 atmosphere. Volume is my question mark, right? How many liters? That equals N, 2.3 moles. My R is my universal gas constant. Let's see, can I switch this color? Whoa, don't do that. Oh, yes, I can, absolutely. I want orange. R is 0.0821, and that is ATM times liters over mole times K. And then I want purple. T equals, they tell me it's STP, so 273 Kelvin. So we're going to say pressure times my volume equals number of moles times R times temperature. 1 ATM times V equals 2.3 moles times 0.0821 ATM times liter times mole, okay, times the temperature. Multiply this side, we get 1 times V. Multiply the right side, 2.3 times 0.0821 times 273, I get 51.55. And then to get V by itself, we divide both sides by 1. I know that seems unnecessary, but I'm just trying to help for those of you that need the algebra. So my volume is equal to 51.55 liters for sig figs. Ooh, that's rough. Okay, just 1 sig fig right there. That's really what's limiting us. So we'll just say volume is 50 liters. Hopefully this helps with the ideal gas law.